On a quiet morning in May of 1919, the sun vanished. Not forever, just long enough to test the limits of reality itself. As daylight dimmed and birds fell silent, a strange twilight washed over parts of the earth. For most people, it was a spectacle. For a handful of scientists scattered across the globe, it was a once-in-a-lifetime gamble. Because if they were right, the universe would never look the same again. 4 years earlier, a little-known physicist named Albert Einstein had made a bold claim. He said gravity wasn't just an invisible force pulling objects together. He said massive objects like the sun actually bent space and time around them. Light itself, he argued, would curve as it passed near a massive body. It sounded outrageous, and there was only one way to prove it. During a total solar eclipse, when the moon blocks the sun, stars near the sun's edge become visible. If Einstein was right, those stars would appear slightly shifted from their normal positions, nudged by warped space itself. In 1919, with Europe still reeling from World War I, two expeditions set out. One traveled to the island of Principe off the coast of West Africa. The other went to Sobral, Brazil. Their leader, astronomer Arthur Eddington, carried more than fragile telescopes and glass photographic plates. He carried an idea that could upend centuries of physics. Conditions were brutal. Heat warped instruments. Clouds threatened to erase the eclipse entirely. In Principe, rain poured until the last possible moment. As the moon finally slid into place, plunging the world into darkness, the scientists worked feverishly, seconds ticking by, hands shaking, knowing they might never get another chance. Then the sun returned. The eclipse was over. All that remained were a few faint photographs and months of anxious waiting. Back in England, Eddington and his team compared the eclipse images to reference photos of the same stars taken at night. Slowly, painstakingly, a pattern emerged. The stars had moved, not by much, just a fraction of a degree, but it was exactly what Einstein had predicted. When the results were announced later that year, the news exploded across the world. Newspapers declared a revolution in science. Newton's universe, solid, predictable, eternal, had cracked. In its place stood a cosmos where space could bend, time could stretch, and light itself could curve. Einstein became a global icon overnight. But the real triumph belonged to a moment of darkness, to fragile glass plates, and to scientists willing to chase an idea across oceans during one of humanity's darkest eras. A reminder that sometimes to understand the universe, the sun has to disappear. If you enjoyed this story, please like, share, and subscribe, and leave a comment below. Your support helps the channel grow and brings more hidden moments of history to light.